Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says subarrays with sum in range. Now the problem is pretty simple, but it is marked as hard because it is not a usual problem where you need to know a lot of data structures, algorithms. It is a tricky problem which plays you with your brain. But without any further ado, let's get started. Given an integer array ARR and two integers L and R, find the number of subarrays whose sum lies in the range L and R inclusive. So we want to find number of subarrays, okay? And a subarray is a continuous sequence of elements within the array. So now with left and right as 3 and 8, with this array we have subarrays as 1, 4, the individual item 4 and individual item 6. So there are 3 such subarrays, hence the output is 3. Same goes with another example 2, where the output is 6. So how do we solve this one? So one such attempt where we can do over here is we can just go brute force approach, where we can take every possible combination from I to j, where we are running from I starting from 0, 1, 2, 3, and for each I we take j from this point to that point till the end. But this approach is not viable because again for each n elements we are iterating n times again, which brings us the time complexity of O of n square. Can we have a better approach? So you see, we can take an example as 2, 3, 5, 8. I'll take 2, 3, 5 and 8 here with the indices 0, 1, 2 and 3. The problem with earlier approach was that we have I and j pointers, and again we wanted to take L and R as 4 and 13. L is 4 and R is 13. So cool. So problem with earlier approach is we chose I and j pointers. Along with that we chose a sum, where sum, if such was a case where I and j both were at 0, then sum would be at 2. And if sum would be at 2, I'll consider 2 not eligible, as 2 is not within the range. Once I move the j pointer, it would be 2 plus 3, which would be 5. Sum is 5 and I can consider 2, 3 as an array element, subarray. Now I can again move forward j, which would be 5 plus 5, which is 10, which is again inclusive. It would be 2, 3, 5. So 2, 3, 5 would be one of this target array. If I increase j again, it would be 18. The sum would be 18 for all, and we are out of the budget, out of the scope, L and R. So what do we do here? We can do one thing, that hey, instead of stopping the loop, rerunning, we wanted to do one thing, right? We wanted to take the sum down. So how can we take that? Either we reset the window, which we are not doing, because if we reset it, we are again on the brute force approach. We take the sum down by shrinking the window. We shrink the window by increasing I. So if I increase I would eliminate this 2. So 18 minus 2, it would be 16. But guess what? We are still out of the window. So take the sum down again, and I'll do I plus plus again, removing minus 3, removing this 3. So minus 3. So it would be 13. But 13 is within the list, and there we go with 5, 8, because I is at 5 and j is at 8. This solution might seem viable, but for some reasons it is not, because it shrinks down or it ignores few of the middle elements. Like on the example 1, if I have 1, 4, 6, it will definitely ignore that. What do I mean by ignoring? 1, 0, 1 and 2 with L and R as 3, 8. So 3 to 8 we are heading. So if I'm at I this, J this, we are obviously ignoring it. J increased by 1, so it is 5. We accept it. So 1, 4 is the first element. Now we again increase J, which brings us 6, 10, 11, which is something we are out of the budget. So we'll shrink down the I pointer. So now it is 10. We'll again shrink down. So it is 6. So we only have 2 elements here. But in reality, we have 3 elements because we missed just a single 4. And there is where the dilemma starts in. Are we going to rely on this or not? Let's see first of all. Can we check this or not? But we are sure at any point of time, if you give me an array along with the target sum, I can ensure you that, hey, I will give you the count of subarrays having sum less than or equal to the target sum. So that we are sure of. Cool. With that understanding in mind, let's get started. I know this is not what we wanted, but let's see. So int, I'll say lesser targets count. I know I should come up with a better naming, but this is what it is right now. So if I have a target, I have an array, I wanted to keep track of sum, from the left pointer and right pointer, considering left is starting from 0 and also right would be also starting from 0, but I'll use that within for loop. R is 0, R is less than a dot length R plus plus. Now at any given point of time, I'll consider sum would be a of R. Now there comes the inspection point. Do we want it to take sum down? That's where I take an if for if sum is greater than target, I want it to take sum down, and that's where I do sum minus equals to a of L and L plus plus. Do I want it to do this once or multiple times? I want to do it multiple times, and hence L is less than a dot length and yeah. So once this is done, I'm left with a count. So I can directly get the count from R minus L plus 1, because this will give me a window and each element would qualify lesser than the target. I'll also include this count, and since we are returning the count, I'll return the count. Cool. Now we have all the elements, all the subarrays, number of subarrays, which has sum lesser than the target. How can we utilize this? And this is where the tricky part comes in. If you have such kind of function, we can just go ahead and say that, hey, if you have this function, just use a and r so that you can get all the numbers lesser than r, all nums lesser than r, and you can just subtract a with L minus 1. So all nums lesser than L minus 1. This will give you a window. The previous one would give you a window, right from 0 right up till R, and the below one would give you a window from L to R. Sorry, the below one would give you a window from 0 to L minus 1, and you are left with L to R, this range. So this is what we wanted. We have this too, so just I have subtracted it, easy peasy, and that is what I would be returning here with a semicolon. Let me try to compile this one. Have I made any compiler errors or what as such? None, it seems. So let me try to submit this for checking on rest of all the test cases. And yeah, it got submitted. So this was one of the very tricky problem. It was not tricky once you understood this part, but it was obviously a tricky part when it comes to the last section. It's okay if you don't get it right at the first instance. It is meant to, because it's sliding window and arrays, not in a usual way. Speaking about time complexity, we respected the time complexity and space complexity. And yeah, for more such sliding window array related questions, click the video on your right, and I'll see you in the next one.